Hi, in this lesson, I'm going to derive the rules or the laws in logarithm. Normally, we call it as rules, is it? Okay, so first, what is meant by logarithm? What is it actually? Now, that is actually something related to logarithm and indices are related to each other. Say, like 10 to the power 1 equal 10, 10 to the power 2 equal 100, 10 to the power 3 equal 1000. So this I can write in terms of logarithm, or I can say I can introduce a new mathematical operator or function called logarithm to represent these indices. How to represent it? I can say this one as log 10 of 10 equal 1, log of 10 100 equal 2. Okay, what does it mean by this way of writing? Now here this 10 is written here. This 10 is written here. The index is written here. This 10 is written here. This 100 is written here. The index is written here. So that means log of 100 base 10 equal to 2. The same way I can write this one, log 10, this 1000 equal to 3. Same way I can write for even any other, in terms of any other base. For example, 2 to the power 3 equal to 8. So this I can write log, this as the base, called base. This is the 8 equal to 3. Log of 8 base 2 is equal to 3. Even for 5, I can write 5 to the power 2 equal 25. That could be written as log base 5 of 25 equal to 2. Right? So that's the meaning of logarithm. Logarithm is something related to indices. So generally I can say, if I say a to the power p equal x, that could be written as, in terms of logarithm, log a of x equal p. That's the meaning of logarithm, right? So actually logarithm is something related to index. Okay, we know that for any number, its power 0 equal to 1. That means we know that a to the power 0 equal 1. That means log base a 1 equal 0. We can use it anywhere when we are solving certain equation. We need this one. That is log of base a of 1 equal to 0. Same way we know that log of a equal 1. That also useful when we are solving certain equation. You can see that in my next lesson. So I'm going to use these applications or these concepts or these methods in certain calculations later. Okay, so there are some rules or laws in logarithm. The first rule is product rule. That is log of x base a plus log of a base a y equal to the same base log a x y. I'm going to derive it. Okay, how to derive it? So I can say let log a of x equal p. So from this I can write, according to the definition of logarithm, a to the power p equal to x. Same way, let log a of y equal to q. That means a to the power q equal to y, right? So I need log of x, y. So I'll multiply these two. So when I multiply these two, I'll get xy equal a to the power p times a to the power q. You know, if the base are same and when we multiply, the index will be added. So that will be equal to a to the power p plus q. Okay, make this as a subject, that is a to the power p plus q equal xy. Okay, now again use the concept or the idea or the definition of logarithm. A to the power p equal x means log of a that comes as the base. This comes here, the index comes here. So if I use the same thing, I can write log a of xy equal p plus q. Now we know p is equal to log a of x. So log a of x plus q is equal to log a of y. Log a of y. So that means I can write these things as a subject. So that I can write log a of x plus log a of y equal log a of xy. So this is the derivation for product rule. Okay, the second rule is quotient rule, that it says, or the ratio, that means log a of x minus log a of y equal log a of x over y. Okay, how to derive this one? So I can say let log a of x equal p. So from this I can say a to the power p equal x. Let log a of y equal q. That means a to the power q equal y. Now look at here, I need x over y. Is it x over y, log a of x over y? So the idea, I should divide this by this. We'll see what I'm getting it. So that means x over y equal a to the power p divided by a to the power q. Both have the same base. So when I divide, the index will be subtracted a to the power p minus q. That is equal to x over y. Write this as a subject, a to the power p minus q equal x over y. Okay, I'm going to use the definition of logarithm again. It says a to the power p equal x means log a of x equal p. So I'm going to use that definition here again. That is, according to this definition, log a of x over y equal p minus q. But I know p equal log a of x and q equal log a of y. So if I write this as a subject, I can finish it as log a of x minus log a of y equal log a of x over y. So this is the derivation for quotient rule. Okay, next thing is power rule. What it says, log a of x to the power n equal n times log a of x. Okay, so how to derive this? I can say let log a of x to the power n equal p. So from the definition of logarithm, I can write this as a to the power p equal x to the power n. Or I can write the other way, x to the power n equal a to the power p. Okay, so here log a of x. So I want to get in terms of x. So take nth root, like square root, cube root, like that. Nth root, if I take it, x equal a to the power p 1 over n. That is a to the power p over n is x. Write this as a subject, a to the power p over n equal x. Okay, now I'm going to use again the definition of logarithm. What does it mean? Log a of x equal p over n. Cross multiply n log a of x equal p. But what is p? P equal log a of x to the power n. So that means log a of x to the power n equal n log a of x. So I can finish it like log a of x to the power n equal n times log a of x. So this is the derivation for power rule. Okay, the next one is change of base rules. It's very useful for when we are solving certain equations. I'm going to show that in the next lesson. When we are solving in simplifying any logarithmic calculations, it's very useful. Okay, how that means log a of x. So log base a x. If I want to change it to base b, that means log b of x divided by log b, b is the new base of the earlier base, b of a. Okay, how to derive this? I can say let log a of x equal p. So from that I can say a to the power p equal x. Then I can say let log b of x, that's a new base, b of x equal q. From that I can write b to the power q equal x. Okay, now look at here. A to the power p equal x, b to the power p equal x means x equal x, we know that. So a to the power p is equal to b to the power p. So therefore a to the power p equal to b to the power q. So from that, take both side peak root because I want to make a as a subject. So that means a equal b to the power q 1 over p, that is b to the power q over p equal to a. Right, so make this subject b to the power q over p equal a. Now I'm going to use the definition of logarithm here. B to the power p over q equal a means log base b of a equal q over p. But I know what is q. Q means log b of x divided by log a of x. But here I want to take a of x as a subject. So log a of x, bring it here, bring this down, equal log b of x divided by log b of a. So that's the derivation for change of base rule. Okay, so by using change of base rule and this one, a to the power 1 equal a, I can get another important relationship in logarithm that says, you know that log a of x, I'm going to write this in terms of base x. I'm going to write it in terms of base x. So that is log, I'm going to change this one to base x. This is base a. So if I change it to base x, so according to this change of rule, log x of x divided by log a of log x of a. Is it? If I change this to base x, log the base is x, so log x of x divided by log x of a. But we know that log x of x equal 1, log a of a equal 1, I already explained it. So this could be written as 1 over log x of a. It looks like a reciprocal, that is log a of x equal 1 over log x of a. Very useful relationship. Okay, so that's the last rule in logarithm. Say log a of x equal log a of y. Then x equal y. Okay, how to derive it? So I can say let log a of x equal p. So a to the power p equal x. Same way log a of y also should be p because they are same. That means a to the power p equal y. But a to the power p, a to the power p are the same thing. It's very simple derivation. A to the power p should be equal to a to the power p. Therefore, x equal y. So this is also very useful in certain solutions. So log a of x equal log a of y means x equal y. Okay, so we heavily use logarithm in science, such as physics or chemistry. So, for example, if we want to solve this one, x to the power 7 equal 45, sorry, that means if I want to find 7 to the power x equal 45, and if I want to find the value of x, what we say, take log on both sides. That's the way we normally say, take log on both sides. Okay, what is meant by take log in both sides? I'll come to that point. But normally, how do we do? By in scientific calculator, you can get log of base 10 for any numbers. So we take log of base 10 on both sides, and we say log of 10 7 to the power x equal log of 10 45, and we use the power rule. That means x times log base 10 of 7 equal log 10 of 45, and x equal log 10 of 45 divided by log 10 of 7, and we can get this from your scientific calculator. So you will find the log of 10 of 45, log 10 of 7, and you will finally get 1.956, and so on. Okay, so that's the way we find the value of x if it is an index of a number. Okay, what is meant by taking log? So students normally have wrong idea. They think we are multiplying both sides by log of 10. No, that's not the meaning, right? Operating on both sides by log does not mean we are multiplying both sides by log, because students have ideas. Say, for example, if it is like x equal 5, I can multiply both sides by any number. I can add any number on the both side. I can divide both sides by the same number. So like that, students think both sides, I am taking log means I am multiplying this by log of 10. No, that is not the meaning of it. So I can say according to this way, if x equal y could be written like this, I can say that way. Or actually, what are we doing when we are taking logarithm here? Say now I can say 7 to the power x. If I derive it by using the basic rules in logarithm, that means 7 to the power x equal 45. Write the normal rule, that is log of 745 equal x. Log of 7 base 45 equal x. Right, now convert this to base 10. Base 10, this one, convert this to base 10. That means log base 10 of 45 over log base 10 of 7 equal x. Now look at here. This and this are exactly the same actually. This and this are the same thing. So actually taking log on both sides means actually we are doing, this is the operation, but it looks like multiplying both sides by log of 10, but that is a wrong idea. Okay, I think it's useful for you, all of you. Different syllabuses have different standard in logarithm, Cambridge, Edexcel, International Baccalaureate, and Sri Lankan A-level also. Right, okay, so in my next lesson, I'll do some questions solving related to logarithm. Okay, right.